Hello, welcome to the first part of Interdisciplinary Science. In this course, we will start with a discussion on properties and measurement. Now, what is the meaning of property of an object? Property of an object. Well, this is an object that I'm holding. It has certain properties. Properties are characteristics. Can you tell me one characteristic of this that I'm holding? It is long, is that right? Yes, that is a characteristic. It is round, well, it's like a round stick. Well, is it heavy? Is it smooth? There are many characteristics that you can assign to objects that you see in your everyday life. Now, objects are studied and classified using their properties. Very often it is useful to classify objects using their properties. What kind of properties? Objects can be big or small. Objects can be heavy or light. Objects can be smooth or rough. Now, if you run your hands along this rod, you can see it is pretty smooth. But if you look at this one here, well, it is pretty rough. All right? It can be, now this is fairly heavy, whereas this is very, very light. Well, what other properties can we assign? You can assign properties like color, smell. Now, this has color. Well, is there anything I can find that has smell? We very often classify objects using their smell. What other properties can you think of? How rigid or flexible objects are. Now, look at this. What property has this got? This is quite flexible. I can use this to tie things. How about this? Is this flexible? What do you think about this? Is this flexible? Well, that is quite flexible. Is it strong? Now I'm trying to pull it apart. Well, it's quite strong, and these are some of the properties that we can assign to objects. Does the object float in water? Well, I have some water here, and I can test if this will float. Tell me, what do you think? Is it going to float or not? Well, that is floating. So this object has this important property that it floats in water. Now, look at this object. What kind of properties can you assign to this? Can you see me squeezing it? Yes, it can be squeezed. And once the squeezing is done, it comes back to its original shape. You think it will float? What do you think? Make a guess. I'm going to drop it in water. Well, it is actually floating. Right. So look at the properties that we can assign to object. Is the object a solid or a liquid or a gas? Has the object got a regular shape? If you look at this, here we have a regular shape. Now, how about this object? Can you see what I'm holding? Well, has this got a regular shape? Well, look at the shiny characteristic of it. It's quite shiny, is that right? Okay. We have now discussed a number of properties that objects might have. Now, what I would like you to do is think of some other properties that can be assigned to objects. I want you to think about it and I'm going to give you an activity. All right? Okay. Now, that is the best way to learn properties of objects. In this course, we will be doing lab activities as we move on with various concepts. What I would like you to do is, before you do a lab, now go to the home page of your course, access the course content. There is a folder which contains the worksheets for each of the labs. So we are now going to look at lab 1, which is study of properties of objects. I would like you to open the lab folder, print out the worksheets. You don't need to print out, you can keep it on the computer, but printing out and keeping it with you will be easier for you to write it. All right, now let's see what the activity is. Now look at each of the objects provided. I have provided a number of objects for you. Now look at these objects. I'm not going to name them, I'm simply going to show them to you. Look at these objects. Most of them are familiar to you. Now, what I would like you to do is look at each of them and then add some more objects of your choice. If you move around, look around, you see I have collected a number of objects here. I just picked it from here and there. If you go around your house, you can pick many objects. So pick some more objects so that you have a total of 20. Make a list of the properties of each object. Well, if you look at the worksheet, I have given you space for that. And then divide these objects into 3 groups based on their properties as shown in the next slide. Again, that is given in your worksheet. Now, look at the worksheet. Now, name the objects and 3 properties for each. In other words, you have divided the objects into 3 groups, haven't you? Well, group 1, name the objects in this group. Alright, I have given you space for doing that in the worksheet. There you are. Now, what is the property that you use to put these objects in this group? Write down the name of the property. Did you use all these substances are flexible? You put them all together because they are big? You put them all together because they are hard? Did you put them all together because they are soft? So, name the property you used which is common to all these. Now go to group 2. Names of the objects in this group. Alright, write down the names. And then tell me what is the property you used to put these objects together. Similarly, go to group 3 and name the objects in this group. Alright, what is the property you used to put these objects together in that group? And when you finish that, I want you to name 10 objects used for building construction. Now in Florida, if you move about, you see always new buildings coming up. Now name 10 objects that are used for building construction and name the property in each case that makes it suitable for that purpose. Now I'll give you an example. Now you use glass for windows because glass is transparent. You see an object I'm holding here? It is a transparent object. It lets light pass through. You can see in building construction, transparent objects are important. There are objects that are waterproof. You see that? So each object that is used for building construction has a property. I would like you to write 10 objects used for building construction and name their properties. Now, now you have to send me a report of your lab, and how is it going to be done? Well, what you need to do is access the worksheet that I have given you and save it in your computer after typing in all this information. Save it on your computer and then email it to me as a Word document. Now, those are important skills that you must develop. So one more time, the Word document that I have provided to you as a worksheet. Now, after entering all the details, after typing in all your answers, email it to me as a Word document. Alright? If you want help, let me know. Well, let's move on to discussing standard for measurement. What is the meaning standard for measurement? When you make a measurement, your friend also should be able to understand what you're talking about. You know that when we use currency, we use a standard. What is the standard for currency in America? It's a dollar. Well, what's the standard for currency in Europe? It's a euro. You see, everybody uses a standard for their currency. Now, measurement is used to avoid vagueness. A standard is used to avoid vagueness. Is that right? Now, suppose I ask you, give me some money. It is very vague, because you look at me, oh, what do you want? How much? Is that right? Measurement is to do what? To avoid vagueness. We must be precise in our measurement. A standard of measurement is called the unit. A standard used in measurement is called the unit. The unit of currency in America is a dollar. The unit of currency in Japan is a yen, and so on. Now, can you suggest a standard for measuring length? What is the standard for measuring length? Well, length is measured using, have you seen this? This is a meter ruler. This is a meter stick. And what you're seeing is 1 meter long. You can barely see the two ends. Well, that is 1 meter long, and this is a meter rule. Now, this is the unit for measuring a length. All right. We are going to discuss only the metric units, although we will discuss some of the old units as we go on. Well, so some old English standards for measuring length. What are some of the old English units for measuring length? They are very interesting. Now, you know them, don't you? Inch, foot, cubit, yard, fathom, furlong, miles. Now, all these units, if you notice, they are all based on human body parts. I remember my father used to use the width of his 2 fingers as an inch, and it is pretty accurate. All right? And foot. Now, whose foot is going to be used as a standard? I believe in the olden days it was the king's foot. Well, is that a standard? Well, apparently that was used as a standard. What is a cubit? Well, have you ever seen people using the length from their elbow to the tip of their small finger as a measure, like this? If I want to measure the length of this, I would say 1, look at that. 2, well, the length of this meter ruler is almost 2 cubits. All right, what's a yard? Well, if this is a cubit, a yard in the olden days was a measure from the center of your neck to the tip of your finger. You see, if you can measure the distance from the center of your neck, say here, from here to the tip of your finger, that was a yard. How is a fathom? Have you heard of fathom? A fathom is used for measuring depth of rivers and ocean. Now, what is a fathom? Now, I'm going to show you what a fathom is. Now, I'm standing on the deck of a ship, and what I'm going to do is I'm going to lower a stone into the water. Look at that. I'm going to lower it until it touches the bottom. There, it hasn't touched yet. There you are. And I'm going to measure the depth in fathoms. And how I'm going to do that? I'm going to pull this string all the way so that it stretches from, where does it stretch? It stretches from one end of my stretch arm to the other. You see that? There you are. That is a fathom. So I say 1, 2, and I can keep on measuring in fathoms. Interesting standards of measurement, isn't it? Well, in the olden days it made sense, it was practical, and people loved it. But it is no more practical for us. So it is time for us to get rid of these units. I know in this country we all still love these inch and foot and so on. It is time for us to leave it aside and take on with the metric system, which is the most convenient form of measuring. Okay, can you suggest a standard for measuring the amount of substance? What does that mean? Now here I have a beaker full of water, and if I ask you what is the amount of liquid or water I have here, what is the unit that we use for measuring the amount of substance? Well, again, some old English standards now it may be interesting for you to look at some of these units. What are they? Tablespoons. Well, tablespoons, mouthful. Have you seen that? Can you go to a pub and say, give me a mouthful of beer? Well, apparently, mouthful was a unit used in ancient England. So, tablespoon, mouthful, well, cups, a pint. Well, that's all right. You go to a pub and ask for a pint of beer. Well, a quart, bottles, gallons, pails, pecks, and bushels. You heard of all that unit, is that right? Peter Piper picked a peck of pickle peck. Is that right? I messed it up. Peter Piper picked a peck of pickle pepper. If Peter Piper picked a peck of pickled pepper, where's the peck of pickled pepper Peter Piper picked? Is that right? All that are using those kinds of units. Now, they were all very interesting, but for us, they don't make much sense anymore. Well, let me give you some relationship so that, let's think about this. 2 tablespoons equal to 1 mouthful. 2 mouthfuls equal to 1 cup. 2 cups equal to 1 pint. Alright, watch this carefully. I'm going to give you a couple of assignments to do now. 2 pints equal to 1 quart. 2 quarts equal to 1 bottle. Isn't that interesting? Yes. And 2 bottles equal to 1 gallon. Okay, in that case, how many tablespoons are there in a pint? Okay, I will not tell you. I want you to figure it out from here and answer this. How many tablespoons are there in a pint? How many cups are there in a gallon? Now, list 2 advantages and 2 disadvantages of using body parts as measuring standards. Well, what I would like you to do is, when you do this assignment, do it as part of the Word document you prepared. When you listen to a lecture, I will be giving you simple assignments like this. I'll be asking you a question here, a question there. Each time you hear that, note down the answer and put it all together as a Word document and email it to me. And that's the way to keep communication going. And that's the way learning becomes interactive. You see, we are not together in a classroom, but I want to make sure that you are always participating in my class. And this is the way to do that. Okay? So, answer these very briefly. There is no need for big answers. And make it a Word document and email it to me. Okay? Let's move on. Now we will look at international standards. Now, so far we were talking about the old systems and the old standards. Now, we must now discard them and embrace the new international standards so that measuring length in America, measuring length in Japan, and measuring length in England will all be using the same length. Otherwise, we might make mistakes. You remember once a space program was abandoned because there was unit conversion problems between parts made in America and parts made in Europe. Why? Because unit problems. So let's synchronize all our units. The system of units used internationally is called the System International, or the SI system of units. That is the system of units used internationally all over the world now. The following are the units and their abbreviations of some fundamental quantities in the SI system. I want you to watch this carefully. Now, length, the unit of length is the meter. I just showed you the meter stick. And the abbreviation for a meter is lowercase m. So length is a fundamental quantity we measure. Another fundamental quantity we measure is mass. Its length is a kilogram. And the abbreviation is kg. Now, have you seen how much is a kilogram? Now, I am holding now in my hand an object that has a mass of 1 kilogram. This is a standard kilogram. So, you can experience how much is a kilogram. So, mass is a fundamental quantity. Its unit is a kilogram. And we use lowercase kg to represent a kilogram. The third fundamental quantity is the time. The unit of time is the second, and of course we use the lowercase s to represent that. Now, we will only concentrate on these three, although I'm going to show you a few more fundamental quantities. Electric current, measured in ampere. We will see that towards the end of this course. Temperature is measured in a unit called Kelvin, and K, uppercase K, is that. The amount of substance measured in the unit called mole. Alright, but as far as we are concerned, at the moment, if I ask you what are the fundamental quantities, you must be able to tell me length, mass, and time are the fundamental quantities. If I ask you what are the fundamental units, don't give me length, mass, and time, because length is not a unit, it is a quantity. What are the fundamental units? It will be meter, kilogram, second. These are the fundamental units. Alright, let's now talk about the fundamental units and derived units. Now, what is derived? Derived from the fundamental, right? So, units of length, mass, and time are fundamental units. Alright? Now, watch it again. Length, mass, and time are fundamental quantities. units of length, mass and time are fundamental units. Now all other units can be obtained by combining fundamental units. What does that mean? I'll show it to you in a minute. Units obtained by combining fundamental units are called derived units. Units that are derived from fundamental units by combining fundamental units properly. For example, the unit of area. If you want to measure the area of a piece of paper, look at this piece of paper. How do you measure the area? You got to measure the length, you got to measure the width. Remember, width also is a length. You measure the length in meters, the width also in meters. So the unit of area is meter multiplied by meter. It is a square meter. If you want to measure volume, how do you measure volume? Well, if you want to measure the volume of an object like this, you need to measure the length, you need to measure the width, you need to measure the height. Length is a meter, length is measured in meter, width is measured in meter, height is measured in meter. So what is the unit of volume? Meter multiplied by meter multiplied by meter. It's a cubic meter, meter cube. Well, so units of area, volume. Well, how about speed? How do you measure speed? Speed is distance divided by time. Distance is measured in meter, time is measured in seconds. So what is the unit of speed? We say meter per second. All these are derived units. In other words, they are obtained by combining fundamental units. Now, what is the unit of area in the SI system we just talked about? I'm going to ask you to write it down and make it part of the document that you're going to send me. So what is the unit of area in the SI system? What is the unit of volume in the SI system? Alright? Just 2 sentences to go along with your previous work. All these things, everything that you do during a lesson, just print them all together in one page and then send it to me. Unit for measuring length. We just talked about it. It is unit for measuring length is a meter. Now, the following is a summary of units for measuring small and large lengths. You see, a unit like a meter, this is a meter, you know that. Now, suppose I want to measure the thickness of this paper. You know how thin this is. If I want to measure the thickness of this paper, can I use a meter rule to do that? That's very inconvenient. So, we need smaller units for measuring very small distances, and we need larger units for measuring very large distances. For example, what is the distance from the Earth to the Sun? Does anybody know that? Earth is 150 million kilometers. You see that? Kilometers away from the Sun. So we need larger units and smaller units. Alright, I'm going to give you some of these larger and smaller units. Listen carefully. Now, you see, these are of great interest for everybody. Everybody should be able to understand and use these. Okay. Now look at the words I'm using. Pico, nano, micro, milli, centi, deci. Now, this is the meter, that is our unit. So, I put that meter at the center here. To the left of that, I have given smaller units. And to the right are bigger units. Alright, so let's start here. I'm going to represent all these using powers of 10. Now, you know that if you raise any number to 0, do you know that? Any number raised to the power 0 is 1. So, the unit of meter, this is 1 meter. I'm writing it as 10 to the power 0. So, 1 meter is written as 10 to the power 0. Let's go to the next. Deci. What does deci means? Deci means 1/10. So a decimeter is 1/10 of a meter. Look at how we write it. 10 to the power of -1. That's the way we write 1/10. Alright, centi. What part of a whole is centi? Centi is 100. How do you write that? 10 to the power of -2. That means 1 centimeter is 10 to the power of -2 of a meter. 100th of a meter. You see, if you look at this, you can actually see the ruler is actually marked in centimeter. It starts from here, 0, 1, 2, 3, 4, all the way to 100. There are 100 centimeters marked on this meter rule. So a centimeter, therefore, if you take 1 centimeter, it is 100th of the whole meter. Alright, let's go to the next one. What is milli? Milli is 1,000. In other words, 10 to the power of -3. A millimeter is 1,000th of a meter. So how many millimeters are there in a meter? If a millimeter is 1,000th of a meter, there will be 1,000 millimeters in a meter. And you can see them also on the meter ruler. In fact, the smallest division you see on the ruler is a millimeter. In fact, I have suggested in the beginning of the course that you must get hold of a ruler and a protractor, a device to measure angles. It's very useful. But at least you must have a ruler so that when I'm talking, you can actually refer to it. You see, the smallest division is a millimeter, and there are 1,000 of those millimeters in this length of 1 meter. So 1 meter contains 1,000 millimeter. A millimeter is 1,000th of a meter. Alright, let's go to the left, to smaller and smaller units. What is a micro? What does a micro stand for? A micro is 1 millionth. 1 millionth, 1 part in a million. And look at the way we write it. 10 to the power of -6. Nano is a billionth, 1 part in a billion. You see? 10 to the power of -9. In fact, have you heard of atoms? The diameter of an atom is of the order of a nanometer. A nanometer. A billionth of a meter. And you see, later on we'll talk about waves and wavelengths. You see, wavelengths of visible light is measured in nanometer. And if you go down further, there is picometer. What is picometer? Picometer is a trillionth of a meter. 1 part in a trillion. You see how interesting these are? Aren't they? I'm sure they are. Okay, now these are the units for measuring smaller lengths. Let's now go and discuss units for measuring bigger lengths. Okay, so here is 1 meter. Now what is deca? A decameter is 10 meters. That is 10 to the power of +1. A hecto stands for 100. A hectometer is 100 meter, 10 to the power of 2. I hope you know these, the notation of power. 10 to the power of 2 is 10 times 10. A kilo, you must be familiar with that. A kilo is 1,000. So a kilometer is 1,000 meter. You see, a very often used unit for measuring distances. On your car, the speed is given in miles per hour, also in kilometer per hour. A kilometer is 1,000 meter. Mega, how much is a mega? A mega is 1,000,000, 10 to the power of positive 6. Giga is 1,000,000,000, and tera is 1,000,000,000,000. So, units for measuring small and large distances. Okay, let's move on. Well, we talked about this. 1 millimeter is 1,000th of a meter, 10 to the negative 3 of a meter. Therefore, 1 meter will contain how many millimeters? 1 meter will contain 1,000 millimeters. I want you to know those simple things. 1 centimeter is 100th of a meter, 10 to the power of negative 2 meter. Now tell me, 1 meter contains how many centimeters? A meter contains 10 to the power of 2 centimeters. Alright, look at the kilometer. 1 kilometer is 10 to the power of 3 meter. It means 1,000 meter. Now tell me now, how many centimeters are there in 5 meters? Alright, I'm going to give you a couple more simple things to add to your assignment. You're going to do this and send it to me. How many centimeters are there in 5 meters? Well, if in 1 meter there are 100 centimeters, of course, this is for little children, is that right? Let's now talk about units for measuring mass. Units for measuring mass. And what did we say the unit for measuring mass is? Well, the unit for measuring mass is a kilogram, and this is a kilogram. Now, here again, so kilogram is the unit for measuring mass. A standard kilogram, actually a standard kilogram is sitting in the International Bureau of Weights and Measures in France. They have a standard kilogram there, and everywhere in the world that is duplicated as a kilogram. A kilogram is defined as the mass of a metal cylinder kept in the International Bureau of Weights and Measures in France. It is exactly like this. Alright. Now, here again, we need to measure very small masses and very big masses. And we will use the same kind of terms. Look at this. I colored this red because that is our unit, our standard unit. Kilogram, not gram. Now, when it comes to a kilogram is how many grams? A kilogram is actually 1,000 gram. 1,000 gram is a kilogram. Now, a gram is a very small quantity. Alright? So we use a decigram, a centigram, a milligram, and so on. So, we will only talk about grams and kilograms. So you need only know that 1 kilogram contains how many grams? 1,000 grams. Well, 1 milligram is 1,000th of a gram, and 1 kilogram contains 1,000 grams. You must know this. You can forget about the others, but this is important. 1 kilogram contains 1,000 kilograms. I'm sorry, 1 kilogram contains 1000 gram. That means 1 gram is 1,000th of a kilogram. 1 part in 1,000 of a kilogram. Okay, the next question for you to add, how many kilograms are there in 500 grams? I want to see how many of you will get that right. If 1 kilogram contains 1,000 grams, how many kilograms are contained in 500 grams? Alright, let's now go and talk about units for measuring area and volume. We actually talked about that, is that right? When length is measured in meter, the unit for measuring area is meter squared, square meter. Now, have you heard of this unit called hectare? That is the unit for measuring large areas. Well, in America we use acre. Now, what is the relation between a hectare and an acre? Now, first of all, what is a hectare? The area of a land 1 meter long and 1 meter broad. Can you think of a field 1 meter long and 1 meter, a field 100 meter long and 100 meter wide. Alright, I'm going to repeat it. The area of a field that is 100 meter long and 100 meter wide is a hectare. In other words, a hectare is 100 meter multiplied by 100 meter, and that is 10,000 meters squared is a hectare. So, if you take a football field, for example, a football field, will it be more than a hectare or less than a hectare? Well, it will be much less than a hectare. A hectare is much more than a football field. It's nice to visualize these things in your mind. Now, when length is measured in centimeter, the unit for measuring area is centimeter squared. For example, if I want to measure the area of this, well, I wouldn't measure the length in meters. I would measure the length in centimeters squared. You want to write this down. I'm going to measure the length of this in centimeter. The length of this is 16 centimeter. Did you write it down? The length of the paper is 16 centimeter. Its width is 11 centimeter. What is the area of this paper? Well, you have the length is 16 centimeter, so the area will be 16 centimeter multiplied by 11 centimeter. What's that equal to? Is that 176 centimeters squared is the area of that paper. You see, length in centimeter multiplied by length in centimeter, you get centimeter squared. That's right. Okay, let's move on. When length is measured in meter, what is the unit for measuring volume? Unit for measuring volume is a meter cube. If you measure length in centimeter, then the unit for measuring volume will be a centimeter cube. A centimeter cube. How big is a centimeter cube? Well, a centimeter is about that much. So if you can consider a cube of side 1 centimeter long, 1 centimeter wide, and 1 centimeter high, that will be a centimeter cube. Well, can you think about this? How many centimeter cube will be in a meter cube? If you send me that answer, you get 1 extra credit point. Well, you got to do it as soon as you listen to the lecture. How many centimeter cube will make a meter cube? Let's see how many of you can do that. Okay, let's now look at this. The length of the rectangle shown here, the rectangle here, the length is 6 centimeter and the width is 4 centimeter. What is the area? Its area is 6 centimeter multiplied by 4 centimeter is 24 centimeters squared. There you are. Area equal to 24 centimeters squared. Now, what is this area in square meter? Can you find the area of this in square meter? Alright, first of all tell me 4 centimeters is how many meters? Well, it's actually simple because 1 centimeter is 1/100th of a meter. Therefore, 4 centimeter is 4/100th of a meter. How do you write 4/100th in decimals? It is 0.04. Is that right? Yes. Similarly, 6 centimeter. 1 centimeter is 1/100th of a meter. Therefore, 6 centimeter will be 6/100th of a meter, which is 0.06. So, the width here, 4 centimeter, is the same as 4/100th of a meter, which is 0.04 meter. And the length will be 6/100th of a meter, which is 0.06 meter. Can you multiply these two numbers and give me the area of this rectangle? What is the area equal to? How would you multiply 0.06 by 0.04? I know some of you may have difficulty with that. Let me see if you have difficulty. What you need to do is 0.06 multiplied by 0.04. First you multiply the numbers. 6 times 4 is 24. Now, if you know how to multiply your decimal numbers, there are 2 decimal places in the first number. There are 2 decimal places in the second number. Therefore, the result of the multiplication must contain a total of how many decimal places? 2 plus 2, 4. Now, I have a 24, the number here. I must write this with 4 decimal places. So what do? I start with this last digit, count 1, 2, and now put a 0 and count it 3, another 0 and count it 4, and put my decimal. That's how I create 4 decimal places. So the answer is 0.0024 meters squared. So 0.04 meter multiplied by 0.06 meter is 0.0024 meters squared. Alright? You must know how to do that now on your own. So the area is 0.06 meter times 0.04 meter is 0.0024 meters squared. And look at the way I wrote this one now. It is 24 times 10 to the power of -4. What that tells you, you see 24 centimeters squared is the same as 24 times 10 to the -4 meters squared. There you are. So 0.0024 meters squared is the same as 24 centimeters squared. Now, let me see if you can grasp this. I'll try one more time. 24 centimeters squared is the same as 24 times 10 to the -4 meters squared. So, what part of a meter squared is a centimeter squared? 10 to the power of negative 4. So 1 centimeter squared is 10 to the power of negative 4 of a meter squared. If you want to convert centimeter squared to meter squared, what all you need to do is multiply the centimeter squared by 10 to the negative 4. Now, that means if you now want to convert meter squared to centimeter squared, multiply by what number? Now 10 to the 1 centimeter squared is 1/10,000th of a meter squared, which means a meter squared contains 10,000 centimeters squared. You see, 100 centimeter multiplied by 100 centimeter is 10,000 centimeters squared. So how do you convert meter squared to centimeter squared? The answer is multiply by 10 to the power of 4. 1 meter squared is 10 to the power of 4 centimeters squared. Alright, I want you to do this now. Convert 0.12 meter squared to centimeter squared. Alright, this is also a part of your work that you need to send it to me. Okay, we have a cube here. The cube is 4 centimeter long, 2 centimeter wide, and 6 centimeter high. What is the volume of this cube? What is the volume of this cube? Can you do that on your own? The volume is length multiplied by width multiplied by height. So the volume is 4 centimeter times 2 centimeter times 6 centimeter. That is 48 centimeter cube. There you are. Now, a common unit for measuring volume is the liter. Have you heard of a liter? Well, you buy Coca-Cola in liters, you buy wine in liters, you can even buy whiskey in liter bottles. You see, a liter is a very commonly used unit. If you get your water bottle and the unit written on it is milliliter. What is a milliliter? Milli is 1,000th. So a milliliter is 1,000th of a liter. Now look at your water bottle. Some of them has 383 milliliter. A Coke can says 255 milliliter. So the unit for measuring volume in the SI unit, a common unit is a liter. Now, a liter is made up of 1,000 centimeter cube. Now, I just told you that a liter is made up of 1,000 milliliter. See, a milliliter is 1,000th of a liter. So, can you connect these two? A liter contains 1,000 centimeter cube. Also, a liter is 1,000 milliliter. Look at the way we write milliliter, small m and big L. And the liter is the big L. Now tell me, what is the relation between a centimeter cube and a milliliter? They are the same. A milliliter is the same as a centimeter cube. Don't forget that. Now look at this beaker. It is written here. I don't think you can read it. If you fill it up to here, it is 200 milliliter. Now tell me, how many centimeter cube of water is in here when I fill it up to here? 200 milliliter is the same as 200 centimeter cube. They are the same. Okay. So tell me, how many milliliter make a liter? A milli is 1,000. So, how many milliliter make a liter? 1,000 of them. So, look at the wine bottle here. That is a liter bottle. Now this is a liter of wine. How many milliliters are there? There are 1,000 milliliters. How many centimeter cube of wine are there? 1,000 centimeter cube of wine are inside there. And look at the water bottle here. It says 375 milliliter is the content of this water. Alright? Can you convert 375 milliliters to liters? Now, how many liters of water are there in that bottle? 1 liter is 1,000 milliliter. Now look at this. A milliliter is 1,000th of a liter. So 375 milliliter will be 375,000. In other words, divide 375 by 1,000. What do you get if you divide 375 by 1,000? I want you to do that and write it down. Okay, what is the relation between a centimeter cube and a milliliter? Alright, they are the same. Alright, what is the volume of the box you calculated in the previous slide? You remember the volume of the box you calculated? 48 centimeter cube. Alright, what is the volume of this box you calculated in milliliter? How many milliliters are there? How many milliliter are the volume of the box you just calculated? I want you to write down that on your own. Now look at the milk bottles. You don't see them in America, but if you go to England, every home in the morning will have a couple of those milk bottles there. Now 500 milliliter it says. Now how many liters of milk are there in one bottle? One bottle contains 500 milliliters. How many liters are there? I want you to write that down and make it part of your assignment. Alright, how many bottles are needed to make 5 liters? If I want 5 liters of milk, how many bottles should I have? Alright, do that and send it to me. Now, our next part of this lesson is ratio, that is comparing to similar properties, and I'm going to leave that. I'm going to tape it as a second part of this lesson. Alright, so I'm going to see you for that a little later.